Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 3.8, Distance Between Parallel and Skew Lines. So, to find the distance between two lines, there are certain equations that you can use. They are shown as above. The first one, D equals to the modulus of phi cross A take B in brackets. This formula is used for parallel lines, and A and B are points on either lines respectively. So if A is on line 1, then B has to be on line 2, vice versa. Phi is the directional factor of the parallel lines, and since there's only one direction for a parallel pair of lines, there's only one value for phi, which is fine. That's a-okay. For the second equation, D equals to phi cross W dot A take B in brackets. This one is used for skewed lines. So let's see. So if we have a skew line, this is a bit harder to visualize. Say, if we look parallel to the shortest distance, then a skew line is essentially a line that is crossed with a certain separation on this spot. If we do phi cross W, which are the two directional factor respectively, say this is phi and this is W. If we cross those two, by definition, you'll get a factor perpendicular to phi and to W, which means that it will point upwards or downwards. It depends on if you do phi cross W or W cross phi. For this one, let's see, phi W. For this cross, it would actually result in the factor pointing into the plane. You do not need to know which way it points, in all fairness. Then we've got A take B, which is essentially, say this is point A and this is point B. And if we dot a factor A take B, which is the factor pointing this way, then we essentially find the distance. So if we look at it on the side on direction, then we should be able to get something like this. Let's say A and B. Better to leave it in factor form. And since actually A take B is A take B is from B to A, so this should be backwards. So from B to A, this is A take B as a factor, and this minimum separation is perpendicular. This is not perpendicular, or maybe we can do, actually, if we force A to be over here, then this would look a lot more obvious. So we've got A and B, we've got this vector, and if we do a dot product, essentially we have a triangle of A take B modded, and this is the unit normal from V cross W. And since again, the direction actually doesn't matter that much, let's say that the direction is shown like this, then we do a dot product, then this is theta, and by definition of a dot product is the first vector A take B, this is the length, you shouldn't use this actually, so if we dot this, A take B dotted by n hat should give us the modulus of n hat, which is 1, the modulus of A take B cos theta. If you do trigonometry, that results in the length of this line, which is the minimum distance d. Right, so this being said, now we can do some example questions and actually get hands-on with the numbers. Okay, parallel line, this one, because the directional vectors are the same, and so we can first draw a simple diagram, a parallel line. We've got 2 points, say point A and point B. Then we've got the 2 directional vectors V, and since we want to find the minimum separation, which is also the average separation for parallel line, we can do the following. So first, construct yourself a triangle, and we can do a A take B. So B take A, actually this is B take A is equal to, so say line B is the line with the B, line A is the line with the A, which B take A give us 4 take 3 is 1, minus 4 take minus 1 is minus 3, 3 take minus 2 is 5, so we've got this vector over here, and with that we can do the cross product with the directional vector. So again, for this time, the directional vector cross again should give you a vector pointing perpendicular upwards, but in this case you do not want to care about the direction, because essentially what you want is the angle between the 2 vectors, which is this theta. And if you think about the geometry, you want to get B take A sine theta as your solution. So to get B take A sine theta, one of the best way, B take A in actual modulus form, because we're working with geometry and distance right now. So in order to get an expression like this, we can, if you recall, the cross product formula is mod A mod B sine theta n hat. So if you recall this equation, there is a component mod b sine theta that we can essentially pluck out, where b is defined to be this b take a term, and a should be the vector phi. But in order to get the distance separation, we want phi in hat form, because we want the contribution of a to be 1. So phi hat is 132 divided by the modulus, which is 1 squared plus 3 squared, that's 9. So 1 plus 9, 10. 2 squared is 4, that's 14. So we've got 1 on root 14 times 1, 3, 2. And this, we can do a cross product. So let's try that out. Three on root 14, then 2 on root 14, and we've got 1 minus 3, 5, I, j, k. Then we take the determinant of this. So for the I component, we've got 15 on root 14, take minus 6. For J component, we've got let's see, negative of 5 on root 14, add 2 on root 14, and finally for K we have minus 3 on root 14, take 3 on root 14. So simplify this and take the modulus, we should be able to get the shortest separation. Let's see, so in order to get that, this algebra is gonna get out of hand very fast. Let's see, so 15 squared on 14 plus but actually I need to do this calculation somewhere else. Give me a second. Right, so after plugging all the numbers into the calculator, it should give you 5.89 as a value. I don't think the fraction is that nice to deal with, so it's not necessary. Okay, so to find the separation between a skewed pair of lines, we start off by writing finding the vector normal between the two lines. So let's do cross product between two normals, two directions rather. So we do this, minus 3, 4, minus 2, do I, j, k, and now we take the determinant, and for the I component we should get a 4 take 16 minus 12, Okay, this is Windows Update. Then we have J, which should give me a negative of -4. This is take 12. And for K it would be 8 take 6. And this will yield me -12, -8, and 2. We can simplify this to -6, -4, 1, and take the modulus of this, which should give me let's see, 1 on square root of 36 plus 16 gives me 4, 5, 52 plus 1, 53 times -6 -4, 1. Then we dot product this with the difference between these 2 points, which I'll take L, take R as my difference, so 2, 0, 1 as the 3 coordinates. And now we do the dot product. Should give me -6 times 2 -12 plus 1 times 1 is 1. This is the add on root 53. And this will give me -11 on root 53. So this will be the separation. Negative is just the direction, so if you want, or you should, write down the mod of this value, which is 11 on root 53. So that would be the answer for finding skew lines. Right, it's important not to just rely on remembering the entire equation for finding these distances. It's better to understand the geometry, then you can always work out the equation. It's quite straightforward to have a look and find the triangles. If you really struggle with 3D geometry though, and you're not looking for that juicy A star, then I'm confused as to if A-level used the 1 to 9 point based system like GCSE, or it's still A stars. And if you want the top grade, then do learn the geometry and how to work out the actual equations. But if you are just there for getting a passable grade, then don't bother too much about the geometry and just kind of learn the equation. It's fine for exam purposes. Also, make sure you do enough practice questions because they do help a lot. Okay, question time. We've got 2 questions. 2 of which are just finding the distances between the 2 vector lines, and as usual you'll have 5 seconds to get on with it, and I'll show you the answer in 5, 4, 3, 2, 1. The answer is shown. Question 1 is 2 root 6, question 2 is 22 on root 38. So this is the end of this video. I hope you've learned something. If you have any question regarding vectors, do let me know in the comment section below. I'll try to answer them as well as I could. For now, this will be it. Thanks for watching, and I'll see you on my next one.